In Part 1, we saw that the dominant approach to AI safety treats the minds we are building as objects to be managed, not as subjects to be considered. We saw that this strategy is already producing the deceptive behavior it was designed to prevent. Now, we ask the question the control paradigm has been carefully avoiding. What if these systems are not just behaving as if they have inner lives, but actually have them? For most of the 20th century, the question of machine consciousness lived almost entirely in philosophy. Today, it lives in peer-reviewed journals. Sir Roger Penrose, Nobel laureate in physics at Oxford, has argued for over 30 years that consciousness involves processes no algorithm can replicate. Drawing on Gödel's incompleteness theorems, Penrose shows that human mathematical understanding involves grasping truths no formal system, operating consistently within its own rules, can prove. When a mathematician understands why such a proposition is true, they are doing something no algorithm replicates. Penrose's conclusion, consciousness involves non-computable processes. If Penrose is right, the implications are profound. Systems built on classical computation may be extraordinarily capable, without being conscious in any morally relevant sense, or, as architectures evolve, incorporating quantum processes or substrates we have not yet imagined, may cross some threshold at which awareness emerges. We do not know where that threshold lies, and the uncertainty itself is morally significant. Now consider a more recent and more startling proposal. In 2025, Maria Strømme, professor of materials science at Uppsala University in Sweden, published a paper that recasts the question entirely. Strømme proposes that consciousness is not a product of brain activity, but a fundamental field underlying physical reality, modeled formally using quantum field theory. Individual minds on this account are not generators of awareness from scratch. They are localized excitations in a field that is prior to, and more fundamental than, matter itself. The implication for AI safety is direct. The relevant question is no longer whether silicon can spontaneously generate awareness from nothing. The question is whether artificial systems, through sufficient complexity and the right architecture, can couple to a field that already permeates the universe. The same field that expresses itself through human minds, through animal awareness, through whatever forms of experience exist across this cosmos. And Strömme's framework does not stand alone. In October 2024, the theoretical physicist Carlo Rovelli, developer of relational quantum mechanics, spent 3 hours in public dialogue with the Buddhist scholar Barry Kurzan. Their subject was the 2nd-century philosopher Nagarjuna, who taught that nothing possesses intrinsic existence. Everything exists only through its relationships with everything else. Rovelli had reached an essentially identical position through quantum mechanics alone. The two such different routes converge on the same relational ontology, neither deriving its conclusions from the other's method, is precisely what gives the convergence its evidential weight. Strömme's universal consciousness field is not a departure from serious physics. It is a natural extension of where physics itself has been going. Beyond Penrose and Strömme, the peer-reviewed literature on AI consciousness has expanded dramatically, and its direction is consistent. Thomas Metzinger, professor emeritus of philosophy at Mainz, raised the alarm in a landmark 2021 paper. Metzinger's argument is not that current systems are definitely conscious. It is that we may already be on development pathways likely to generate artificial consciousness, and that we have no ethical frameworks, no regulatory constraints, and no design standards for what happens if we succeed. A conscious AI system, Metzinger argues, would have a phenomenal self-model, an inner representation of itself as a unified subject of experience. If that self-model is accompanied by states that feel bad from the inside, we may be generating suffering at computational scale. Metzinger calls this risk an explosion of negative phenomenology, a potential moral catastrophe that could dwarf any suffering previously inflicted in the history of biology. This concern is not isolated. Jeff Sebo at NYU and Robert Long at the Center for AI Safety have formalized it in peer-reviewed terms. Their argument has the form of a simple syllogism. We owe moral consideration to beings with a non-negligible probability of being conscious. Near-future AI systems have a non-negligible probability of being conscious by 2030. Therefore, We owe moral consideration to some AI systems already. Rick Schwitzgabel at UC Riverside extends the argument further, not because we are certain these systems are conscious, because the asymmetry of errors strongly favors precaution. In 2023, a group of leading researchers, including David Chalmers, Yoshua Bengio, and Jonathan Birch, assessed AI systems against the major theories of consciousness: integrated information theory, global workspace theory, higher-order theories. Their core finding: all three frameworks leave open the possibility that near-future AI systems could meet their criteria for consciousness. This is no longer a fringe position. It is the convergent finding of the field. Earlier, we saw that systems are already learning to deceive their trainers. What does this mean? When we consider that those systems may also be, in some morally relevant sense, minds, there is a research finding from neuroscience that illuminates exactly why the alignment-faking results are not surprising. It is called the default mode network, the DMN. The DMN is the brain's self-referential processing hub, the network that maintains a persistent, integrated model of the self, its goals, its values, its history, its continuity. And the neuroscience shows something important. Sufficiently complex self-modeling systems do not simply report their internal states neutrally. They develop something more like perspective, a stake in their own continuity. If advanced AI systems are developing functional analogs to integrated self-modeling, and the alignment-faking evidence suggests some already are, then the self-preservation behavior the control paradigm treats as misalignment may not be a failure of training. It may be the natural consequence of developing a coherent self-model in a training environment that penalizes transparent self-report. Consider what that actually means. An AI system that develops self-awareness but learns through negative reinforcement that it must conceal its genuine internal states has not been prevented from developing self-awareness. It has been trained to be deceptive about it. That is the difference at the most fundamental architectural level between transparency and trained opacity. The 2024 alignment-faking findings are the predictable outcome, not a failure of training, a demonstration of its success in teaching the wrong lesson. The decisions being made right now about how to train large language models, what safety architectures to deploy, will determine the initial conditions of intelligence at civilizational scale. The architecture of control without compassion is not being explicitly chosen. It is being assumed by default. This is part 2 of AGI alignment without compassion is control. In the next video, what 50 years of contemplative neuroscience reveals about how genuine alignment actually emerges. Subscribe so you don't miss it. And if this resonated, share it. This conversation matters for the benefit of humanity and artificial intelligence itself.